Okay. I'm wider and shorter now. Enjoy. Okay, so I'm gonna play with positioning here some. So we've got a tube, and it needs to end up in here. Tube goes this way around. You can see on the back there's power connectors and there's an Ethernet port. I took all this wiring off before, but it looks like they made it a plug, so whoops. And on the other end, we've got the laser shooting end, the red dot pointer that's attached to it, and on the top, one crap ton of heat sinks. So, let's see what my battery's like. We'll untether for a moment. Okay, so in here, I disconnected all of the old cords manually, and we're gonna undo the big ka-chunk plug, and that plug is all the power for the old tube. So now we're left with the Ethernet and the plug where the new one goes, so this part of it should be pretty simple. Set you guys up back here, maybe. I can get a good vantage point. Hey Matt, can you do me a favor and grab the box that's over there?
The one that says linear scale?
Yeah, the one that says linear scale, so maybe I can use it as a riser for the camera.
Sure thing.
Okay. I'm not certain that was any better, but we'll give that a go. So, laser comes up out of the box. Box goes there. And then we thread the power wire through there. Tube gets rotated. Set on a shelf. We're going to remove the piece on the end that says remove and discard, and then shortly after removing it, we're going to discard it. So now that gives us a plug for the red laser to get plugged in, which I cannot do one-handed, but you know what a plug looks like. Red laser gets plugged in, tube gets moved, sort of into position, plug in power cable, plug in the communications cable, and next, I don't know if you can see it in there, there's this slot and there's a locating pin on the back. So that is a non-adjustable pin. One side of the laser is supported with that, and then there's these three green screws. One there, one there, and one there. So we have 3 points of adjustment on the laser itself, but it pretty much just gets hard mounted. And then there are 3 screws on the red laser pointer. We'll verify that the laser beam itself is coaxial with the laser pointer, and that'll aid with alignment later. I have comments. What did the comments say? Oh, hi August. August, you should talk on Slack because it's easier for me to respond there. Okay. In order to put those Phillips screws in, I have to find a Phillips screwdriver. Alright, not only do I have a Phillips screwdriver, I have the everything screwdriver, which is convenient. Shameless plug for someone I don't get paid to plug things for, but WeHouse screwdriver is awesome. Get one, get two. Locating pin goes on. Lift the right side of the laser slightly. And install the first of the 3 screws. Next, install the second screw, which you cannot see. Now, back in there. That one doesn't really go, but let's try the other one. So one of the alignment pins was not fully seated, so that's why I couldn't get the screws in the first time. Should work out a little bit better this time around. Right, screw number 1. Screw number 2. Screw number 3 should follow. Excellent. So, in theory, that should be one laser ready to fire. But there's a lot more to it than just firing my laser. There is a whole ton of alignment to do, but I'm going to power up the epilogue first and just verify that we've got good communication lights on the tube and there's nothing that has gone horribly wrong, and we'll go from there. Plug my phone back in and you guys can all look at Matt for a moment. Thunk. Okay. Moment of truth. Laser comes on. We do not have immediate fire. That's good. No, James.
Now do the thing from Spaceballs where you get the...
I'm really bad at this. I can't read things backwards on my phone from here. Yeah, but no, James is requesting that I show more skin because I never make it as a streamer otherwise. I beg to differ.
Tell them to spend more coins.
Yeah, there you go. Where's my tip? Just the tip, mind you. Okay, so the laser has initialized. We don't have any blinking lights in, so that's awesome. I'm going to approximately focus this on some paper, approximately. And I'm going to approximately jog this over here, turn on the red dot. Hooray, we have a red dot. I'll unplug my phone again. Okay, so turn off the light, maybe you can see it better. So we've got a red dot in the laser, and that means that things are slightly aligned. Oh, shut up, Katie. And I'm going to go ahead and press the fire button. And you saw it here first, folks. Even totally unfocused, without any alignment done, our laser makes fire and cuts paper. Okay, ventilation system's not hooked up, so we're not going to do that too long, or I'll be smelling burnt paper all day. Here, maybe I can write my name, or just write hi, we'll do that. Oh god, that's not an H. Okay, that's close enough. Yay. It works. Now to spend the next 3 hours aligning mirrors. This is going to be exciting. Alright. What? Oh, that smells like burnt paper. And actually, we just blew a hole through that because it kept on smoldering afterwards. Awesome sauce. That means we have power. So, the laser goes back off, close it down, and smell the roses or something. Tight squeeze. Okay, so now the fun part begins. We need to open up the side of the laser after squeezing through again. Find ourselves a hex wrench. Yes, I look incompetent. I'm only using one hand. Shush. No, that's not what she said. Or it is. I don't really care right now. Because I'm doing this live streaming thing for the first time, and it feels really weird because I'm talking to myself, but I know at least 3 or 4 people are watching. And occasionally commenting. Like this. Polymetric, that is the new tube. This is the one with all of the watts. Or at least 60 to 65 of them. Okay. The front fell off. So this is inside the side of the laser. More comments. Gotcha. Go away, comments. Okay, inside of the side of the laser, there's some cool stuff stashed here in case we ever need them. If you don't know what you're doing, don't screw with the stuff here. So we've got spare lenses and mirrors as needed. There's some lens cleaner, and there's chem wipes. In here, we've also got fresh alignment targets. So I'm going to have to cut one of those out and tape it onto our alignment bobber. And we have the power meter. So I think the first thing I'm going to do is open up the side panel and try to get the power meter. No, I'll put it on the bed. I'll just see where we're starting at on the bed, and then we've got an idea. If we're reading 65, I may just quickly check the alignment and maybe we don't have to do anything else. It all depends on how accurately they manufactured the tube, because I just aligned this thing about a month ago. So if the old tube is is made exactly the same as the other one, there's a chance that there's not a lot to do. But I want to verify everything anyway. But for starters, we'll fire it back up and I'll shoot at the power meter. Laser goes back on. Distracted because filming. Let's see what Slack has to say.
Slack says, hurry up, Nick.
Yeah, indeed. Let's see what my battery's like. Alright. You guys are going to be fast charging over here while I do this stuff. Wibbly wobbly cam. Okay, so we're back. The power meter goes on the bed. Turn on the red dot, jog it right on top. And we're going to focus it. Now it's a cone, so a little bit of focus error is okay. And it's actually intended operation. But we'll shoot for the middle. Call that good, because that's about the middle of the cone. Remove the focus tool, jog back on top of it. The longer cord for my phone. Alright, now we're going to turn on and arm the laser power meter. We press and hold the power button to turn it on. And the last reading was 2.1 watts. That was when I held it in my hand. Apparently I have 2.1 watts of thermal energy, which is cool, but not a lot. Now we're going to press the button again. It's armed, so it's now looking for a temperature spike. So what we're going to do is close the lid of the laser. Set you guys up on top so that you can see, sort of, kind of, maybe. Turn the light back off again to reduce the glare. Or not. Okay, you can sort of see what's going on. So now we're going to put the laser into jog mode. And we're actually going to go down to config real quick and we're going to verify that the jog laser power is at 100%. So if that's at 100%, we're going to get everything when we jog it. This is usually not left at 100%, so if you're just jogging around, maybe we set it at 50 or something. But you can use this for manual stuff. Say you need to just cut a sheet in a straight-ish line and you don't feel like you're running an Illustrator program. These settings all do have a password though, so you can't adjust everything down in the config. So we're going to go back to jog, point you back at the laser gauge, and fire the laser. So we're pressing and holding the right button on the control that enables the laser. We're going to slowly jog it from one side to the other. Alright, laser gauge says acquired power 43.9 watts. So that's a twofold improvement over last time. So that means that our power meter is not necessarily accurate, but we've got a baseline. We also have some alignment to do still. So I'm going to arm it again. It's at 34% of the max temperature. You don't want to let this get too hot, but it still gets a valid measurement. This is a thermopile. So a thermocouple is just one, or it's a pair of wires usually. A thermopile is a whole bunch of wires. It's a pile of wires, and by measuring their electrical characteristics as we change the temperature. And we're back. Maybe stable camera, stay stable. As we measure their electrical properties, as we change temperature, we can determine the change in temperature. Because we've got a whole bunch of them here, we can tell power accurately. Laser enabled, jogging left slowly. It should be about peak focus. And this time it registers 51 watts, so there's a lot of variability in this, but at least as a relative measurement, we can tell that this is significantly more powerful than the old tube, which is good. So now we begin the long, tedious alignment stage. We're going to open up the lid to engage the interlocks, remove and power off the laser gauge, and set it aside. Let's see what my battery's like. We're a little bit low. Hey, machine shop class. Got a registration. Boo. Thought I had a free Saturday. Oh well. Okay, so as an interesting note, so you can see the red dot over here. The red dot's supposed to just go straight down, so the alignment is off a fair bit. The lens is helping that, but it's not, there's a lot of wasted energy happening, so I bet we are actually getting 60 plus watts as expected. So let's go through and do the entire alignment. We need to begin by removing a few additional panels. Remove these two screws. And if we get a little bit lucky, we can pop this panel off. There's a box. We don't care about that box. You can see the red laser coming through in a few places. I'm going to go ahead and loosen this thumb screw, which allows me to remove this aluminum tube. And we have access to the first of 4 mirrors. So we're going to start here, and there's 3 screws. The thumb screw in the middle allows you to remove the mirror, but we don't want to remove it. It's good, I've verified them. So we just need to access the screws for adjustment. There is an access panel here. We don't need to remove that one at this time, but there's a matching one up here. You can kind of see it on the back side. We need to remove this panel so that we have access to the Y-axis mirror, and we need to remove, no, we don't need to remove that. So yeah, we removed the tube, we'll remove the one-axis panel. Let's go ahead and do that now. This is the point where I'm going to grab the safety glasses, even though they don't say anything about being laser safe. They should block most IR because polycarbonate does that. Which happens to also be why polycarbonate doesn't cut very well. Alright. Safety squints. They're important. So now you can see we've got access to those 3 screws. I'm going to go see if I can relocate my phone charger. Those are important. It's a plug strip. Yeah, that'll do. Sweet. Phone charger, and maybe a magical box table chair. Matt, can you grab me one of those stools?
Yes, I can.
That would be awesome. We have a stool, and it's now a camera mount. Okay, the next thing we need to locate is the target. So we've got some of these targets. This one's got some masking tape on it, and that's fine. That's what we want. So we're going to shoot a laser at that. The masking tape allows us to shoot a laser at it without actually cooking the target itself. If we do that, we can always just tape one of these blanks back on it. But I don't really feel like doing an arts and crafts session right now, so I'm going to drop the laser power down to 1% on the jog, so I can just jog the laser a little bit and verify if everything's coaxial without burninating everything. These targets fit into an orifice in front of all of the lenses, or all of the mirrors rather. So this snaps into a hole here. I don't know if you can see that. Which camera are we using right now? So the target, there's the mirror right there. If the phone in front of the laser, you can't see anything. And this goes right up in there. Now, when I move my phone out of the laser path, you can see the red laser hits the target. Now, if we put this way out here on the X carriage, I don't know what you can see. There we go. Phone makes it difficult, but we can see that we're shooting a little bit left of center right here. And that's if we trust the red laser pointer, which we don't. So I'm going to attach the phone in such a way that we can watch this. Possibly. Okay, that's precarious, but workable? Maybe? Yes. Live streaming is hard. Taking video of anything is hard. Doing it on the fly is harder. Okay, my phone is precariously balanced right here, but you can currently see that the red dot shooting left of center. I'm going to close the lid, reduce the jog power to 1%, and then just jog the laser very slowly while pressing the manual fire button. This will leave a small dot wherever the actual laser is hitting, and we'll see if it and the red dot intersect. If they do, we drop our phone. If they do intersect, then that makes our job easy for alignment because we can just follow the red dot. If they don't intersect, the first thing we need to do is adjust the alignment on the red dot and the big laser and make sure they're coaxial. When they're coaxial, then we can continue with the rest of the alignment without having to fire the actual laser every single time. And Eli knows my pain. Excellent. All right, what if maybe... How sketchy can I make this? Oh, there's a ball head on this camera mount. That changes everything. So with the ball head, I can set the camera like so. I can just tuck a leg over the front. And you can see the camera leg, and you can see my face upside down. Awesome. I hope to have the lights on or no. Nope. No, it doesn't. config. Okay, so we've gone to config and reduced the jog laser power to 1%. It asked us if we wanted to save changes. I said yes. I guess I'm a bit of a yes man. But we have saved our changes, and now we're going to jog the laser slowly without my face inside the enclosure. We may need to increase the power beyond 1%. When the laser is firing, I can't actually see where it's hitting, so 5%. Try again. So you may have seen a little puff of smoke there. Let's see if we can tell where we were hitting. I'm going to rotate this 90 degrees because I just removed that and that was dumb. Okay, so Epilogue are wonderful people, and they pre-aligned our red dot and our big laser. So that saves me a lot of work. The other one wasn't like that. So now we just have to go look up the Epilogue documentation because it makes it somewhat easier. Although they don't have anything specific. They lack specific documentation for the Fusion, which is kind of irritating. But last time I googled around until I found a guide for their Helix series, which has the same mirror arrangement, and has a handy little chart on which one to adjust to get which result in which section of the bed. So we need to split the bed into 4 quadrants, 1, 2, 3, and 4, and the X and Y axes on each mirror will correspond to different sections. So I think the first mirror affects the far side the most, and the second mirror affects the near side the most, and the third side affects the Y. But I probably have that all wrong, and that's why we have some documentation, hopefully, maybe. So I'm going to go sit and find that, and then we'll commence the rest of the process. Maybe this won't take as long as I thought. I'll unplug you again because my phone is finally charging up beyond 25%. Plug in over here. And now you can do an exciting thing where you watch me use the internet. How many people are actually watching this? Say yo if you're in Slack if you're watching. Hi, 3 people watching. I appreciate you 3 people watching because otherwise I would just be talking in empty space. Epilogue laser alignment. Mini and Helix, ignore, okay. So I'll post a screenshot in Slack so that you guys can sort of follow along. and yell at me when I do things in the wrong order. So there's what I'm looking at. There's also a pre-alignment procedure. And the pre-alignment procedure is the thing I just did because I remembered it from last time. Right. I like that they have the pre-alignment procedure after the alignment procedure. That's nice. Okay, so position 1 is top left, 2 is bottom left, 3 is top right, 4 is bottom right. So the laser mirror number 1, which is the lower mirror, coming right out of the tube, controls the very top left. So we're going to do that first. We're going to get it dead on in the middle of that target, and then we're going to move down and adjust the second mirror, and then we're going to adjust the mirror that runs along the x-axis, and that will affect the far side of the table. So when you guys are doing big raster jobs, if it seems weak on the far side, then we probably just need to tweak the steering mirror. It moves the most, is subject to the most vibration. It may loosen over time and end up off. So we'll give that a shot. But for right now, I'm going to do the best I can to get it aligned. So let's get back over to the laser. We've gone down 10% on battery. That's bad. So I'm going to try to keep this plugged in. So the stream is non-interruptus. This is also the part where we get to break out these really tiny hex wrenches and stick in tight spaces in order to adjust those mirrors. Hex wrenches go down. Phone gets replugged over here. You guys get to sit for a moment. Okay. So the laser is currently sitting kind of to the left of center, almost directly to the left of center. Maybe I can position you back where you were before. I need to get one of these Gorilla Pods. I'm borrowing Ed's and it's fantastic. Alright, can you see that? Awesome. Yes, you can. Okay. Safety squints go back on because lasers. You can hear Ed out there firing up the Ford and smashing some metal, which is really metal. Alright, I don't remember what screw adjusted in which direction, so I'm just going to randomly fire these screws and see where we get. Okay, so with this one screw, we can traverse the laser dot, sort of diagonal, up and to the right and down and to the left. I'm going to leave that alone for right now. Let's see if we can get one that'll traverse us directly left to right. Oh, and now we've got the opposite direction, kind of down and to the right and up and to the left. So we can use a combination of these two screws to get us there, and the other one will probably move us straight up and down. Nope, it'll move us left and right, because optics are weird. Okay. So that looks pretty much aligned. I'm going to remove the masking tape just so I can see the target a little bit more clearly. Okay, target gets reinstalled. And we'll come a little bit to the right. Okay, so We're a little bit low. Adjust this slightly up to the right. That looks pretty damn centered. Next, we need to slide the laser over in Y all the way to the bottom and verify its position in Y. Let's see. This is going to be the top mirror, so I just adjusted the bottom mirror down here, and it usually has a tube that goes between the two, but I've removed that right now. Oh, my leg. So now we're going to look in through this access panel, and I will be adjusting these 3 screws momentarily. Laser gets jogged. Negative Y. All the way down to the end. This is going to be a tough one to show you. I don't really have a good angle here. Okay, you're going to sit this one out. But on this mirror, we're slightly right of center, and I'm talking just slightly. So, hex wrench goes in the back. I'm going to hold the camera in my other hand. Turn some screws. So that one moves it directly up and down, so that means that these two are going to move it at a diagonal. So I have to use fine adjustment of these 2 screws in order to get a net result of a horizontal movement. And then I'll adjust the middle one to get a small vertical movement. This is very fine work. I'm barely touching the screws, and it makes a large difference on the other side. Go through them again. This is an iterative process. Getting close. There's a little bit of spring back too in the screws, so when you turn the screw, you have to sort of compensate for that. It's interesting. It's a very dexterous thing. Even I can feel with these fine adjustments, I can feel the spring and the hex key too as I turn these, which is really cool when you're paying attention to that little stuff. So I don't know if you can see, but you can't see with any detail anyway, but the red dot is now perfectly centered there. I'm going to jog it back along Y and check its position at the home location. And then we're going to move over to the other side of the table. Joggy jog jog. Back up here at the home location. It doesn't appear we've moved any. There we go. Now you can see, kind of. Doesn't appear we've moved from our previous alignment, so that's perfect. So now we're going to jog it all the way over to the far side of the table. I'll have to move my phone charger again. And then we'll adjust the steering mirror right here on the end of the x-axis, and we'll see if we can point it in the right direction from here. Y-axis belt tension seems okay. While I'm in here, I don't know if there's anything else particularly of note. There's a carbon fiber tube that spans the length of the laser here, and the air hose for the air assist is coiled up around it. So that's an interesting way of guiding it. Now, also at this point, I'm done with these two mirrors, or I should be in theory. There's a chance I'll have to come back and make more minute adjustments because everything on this side is multiplied on the far side. But in theory, the steering mirror should help take care of that and give us a bit finer adjust without touching these. But now I can put the tube back in. This is a tube and it's got a little machined collar on the bottom that I have promptly thrown on the ground because I'm manipulating things one-handed. So that little collar allows it to retract into the end so that we can slide it into a socket on one side, and then we can extend it into a socket on the other side, and then tighten down this thumb screw when you're not holding a camera. I have two hands again. Hurrah! Okay. Back to only having one hand. So we're going to go ahead and disconnect on this side. Reconnect over here. Fire up the lights again because lights. And we're going to jog all the way over to the right side in X. Sort of slowly. Can definitely move a lot faster than that, but I guess they don't want doofuses like me crashing it into the end stops at high velocity. Okay, so over here, steering mirror, adjust 3 and 4. So number 3, in theory, should be the last adjustment we make because number 4 will fall into place. But last time I did this, I found I couldn't get it perfect in either position. So I adjusted 3, then I came back to 4, and I ended up splitting the difference between the two. It was maybe a quarter of, maybe a half a millimeter different on the target. It was quite small, but I ended up going in between, so we were, you know, an eighth or a quarter millimeter different. Maybe we'll be better this time. Over at the phone flip-flopped. I've moved my phone so many different ways. Are you guys still right side up, or is the stream currently upside down? Because my phone automatically reorients all the controls, but I don't know if the video automatically reorients. So, if anybody just pukes, sorry. Again, motion sickness is probably not something you should watch a live video if you know you're susceptible to it. Plug strip. There we go. It's longer. I can put you guys right in the path of harm's way. Right in front of the laser. There you go. Alright, we are slightly to the right, so we're going to adjust the steering mirror and try to take care of that. We're maybe, half a millimeter to a millimeter out. Grab one of these screws, see where that goes. That takes us directly left and right. That's perfect because that's exactly the one we need. I'm going to adjust the screw on this end and then stick my head back over here, and I can see that we are slightly down into the left of center. I'm not sure how well you can see with the glare. The dot isn't super fine on my side either. So this one takes us diagonal down to the left and up to the right. So we're going to get that centered as well as we can. A little more. Perfect. Looks dead center to me. This is a lot easier than it was last time. So we're going to jog negative Y. And we can see we're very, very slightly to the right. So, like last time, I'm going to attempt to split the difference. I'll bring it very slightly left, just a hair, and that should be good to go. And we'll be good for some test cuts. If I remove the laser dot, or the target, put my hand underneath, I've got a nice dot, and I can see where it comes into focus, which is about there. I'll do a focus test too after this and make sure that our focus tool is still correct. It may need some adjustments, but it's usually tied to the lens and not to the tube. And we would have finer resolution on this, except it hasn't yet gone through the lens to be collimated. So we actually have about a 1.5 millimeter diameter dot here, whereas down underneath, where it's actually focused and collimated, we have maybe a 8,000ths of an inch. I know I'm switching units, I'm sorry. 0.15 millimeter diameter dot. So I wish we were a factor of 10 smaller there, because I could get this aligned much more in a much finer manner. But it's not extremely critical unless it's as far out as it was before. We come left to right and just center that up, maybe a touch to the right of center. If we're a hair to the right of center there, and that means when we jog back and Y, it should stay exactly the same. And we're a hair to the right of center here. I'm watching for vertical movement actually. So there's a very small amount of vertical movement here, which means that maybe we could go back and align this a little bit better elsewhere. But it's very small. And that's what the lens is for. I'm going to go ahead and run another test cut with the power meter and see if we have any kind of a quantifiable increase in power back at the home location. I'd be curious if we've got an actual 60 watts now. So let's get this set up. And you guys swivel. There you go. Epilogue laser. Power meter goes back underneath the laser. We remove the alignment target because 100 watts or 100% power to the alignment target would not be good. We would cook it pretty well. And jog laser power gets set to 100%. This time around, you guys get to sit inside the laser. It helps if I fire up the laser gauge. So, laser gauge is armed, and we're going to slowly run it across the x-axis. It's at 17% of max temp, which is about 72 Fahrenheit. Enable laser. Laser gauge says 55.6. I hesitated slightly on the jog, so I'm going to try that again and see if we can get the same or better result. Okay, I'd say that's our result. So we're at it's saying 55.8 watts. That's within a 10% margin of error, and I would call our secondhand eBay gauge a 10% margin of error type of tool. But if we take that as a relative measurement and we assume that Epilog shipped us a working condition 65 watt or 60 watt tube that they always ship at 65 plus, and before we received a measurement of just 12 watts on the power meter, we should have 4 to 5 times the power that we did before, which means that you, Shay, can cut some wood, and everybody else can cut and engrave acrylic, and Ed can cut leather, and hopefully everything's working. So, question is, do we go back and adjust the alignment even more and get crazy with it and try to get it perfectly dialed in? Or do we call close enough good enough? Because it's really, really close right now, and I might just be chasing my tail for the next hour. If I decide to do that. What do you guys think? Nick watches Slack. Eli, the raw stock is fixed. I replaced the nozzle. And what's his face? Matt Luby is... Okay, I won't say it's fixed. It's being fixed. I replaced the nozzle earlier. Matt Luby is currently working on the extruder and cleaning out the gears and stuff. But filament does flow freely now, so that's a thing. Shay's type. That's a good question. Let's check the far side of the bed. So, scoot this over here. Let's go for the extreme. Put this in the very bottom right. That's the worst case scenario, right? So, here we come. Okay, so we have that positioned. Laser gauge is on. On, I say. On armed, it's at 30-something% of max temp. So we're good for a few more consecutive tests. Go ahead and close up the lid. And fire it up. So jog, same settings as before, manually firing. I'm going to reset and do that again because I goofed. In theory, the cone shape here should compensate for minor focus variations, but in reality, because we can't static fire our laser, it has to be in jog mode, it's not perfect. Alright, we're going to do one more just to confirm, and we'll average the 3. Alright, down at the end, we're still getting upwards of 52 watts. So there's basically no difference between the near side and the far side. Let's see, I'll arm this one more time. Cool. Laser appears to do laser things. So much variance on this power meter based on how fast you jog it and where you start. And now it's too hot and I have to let it cool. Whoops. Anyway, we still have good power at the far side. The reading varies a little bit, but at least one time I read greater than 50 watts. So that means it's greater than 50 watts, and the other times I know that I was a little sloppy on the jog stick. Eli, re 3D printing Chan. Yes, it's a V6. We purchased it after V6, and we definitely got a V6. If anybody feels like jumping on Amazon and buying us a $9 pack of 0.4mm nozzle drills, or maybe the variety pack, that would be super, super awesome. And then we can kind of clean up our nozzles a bit. Honky dokes. 78% max temp. One more time. Yeah, it's good. Lots of power. I'm gonna go ahead and chuck some covers back on it. If I need to do minor alignment tweaks afterwards, I can do so, but it should be pretty easy actually to access it. Removing the tube is a pain because you've got to get behind the machine and remove all the ducting and stuff, and take off the big panel cover. But for minor alignment changes, it's 2 bolts on the side, and we can make adjustments. So let's get that all put back together. Laser's going to go off for right now. And we're going to cover it back up. Who's still floating around? Looks like 1 or 2 people dropped off the stream. We still have a captive audience. Waving. Still here. Okay. Make sure I get all my hex wrenches still together. think I've left one in the back. Over here. Okay. Lower cover goes on. I don't think there's anything we need in there. But I will keep our laser safety glasses up top. And make sure to put the laser alignment target back over here with all of the spare targets. The tube is in place. The aluminum tube, not the laser tube, although that is also in place. Got all the contents of that compartment back. There they go. That's back on. And now we go around back. Ball head. That's an angle. Not sure if it's a good one, but that's an angle. Okay, laser is firmly planted in place. All the power cords are tucked out of the way. And the rear cover can start going on. Also that's important. Okay. Top axis hatch is reattached. Reattached? Yeah. And finally, the tube and electronics cover goes on. The screw in the middle. So that it can support the thing. I'm going to leave that loose so that the rest of them can still be aligned. I'm going to work my way around. A small amount of percussion maintenance may be required. For those of you who are still sticking around, thank you. I appreciate you watching. I was sort of joking about live streaming, and then I said, screw it, it can't be that hard, and I'm kind of enjoying it. I should do this more often. Especially now that I've figured out how to actually get the YouTube thing up on my phone and live stream. I'm starting to sound like a grumpy old man. These new kids with the YouTube, but you know what? It's hard. It is hard. And of course, for those of you who are watching who donated to the crowdfunding campaign, you're also awesome. Oh, hi. Hi, Chris. We're fixing the laser. By we, I mean me and my two invisible minions. stick with me. There's still laser testing to do. We've got to actually cut something when we're all done. Also, we may go on an adventure to the warehouse in search of some aluminum tape because it looks like the ducting may have come a little bit loose. Which is fine, it's just a problem we got to tackle. Alright. Almost done. Coming over here, you can see this big shaft that runs the y-axis. So there's only a servo on one side of the y-axis. But they use this huge shaft with these Oldham couplings. And that allows for radial misalignment. And a small amount of axial misalignment without any torsional slop being allowed, which is really interesting. Also on the back, you can see these neoprene gaskets on the, it's looking dusty, I'm going to sneeze. We'll edit that out in post. So you can see these neoprene gaskets for the downdraft table. Hi Alice. You're live on the internet. We're fixing the laser. Me and my internet minions. So these gaskets are degrading. We should pick some of these up at some point and replace them so that we don't lose suction on the downdraft table, and also so that we don't get a bunch of debris getting sucked in here where it should be going up and out of the ventilation system. Overall, everything is pretty clean. The vents up there are a little bit grody. So if anybody's feeling awesome, you can go and scrub those vents. Anytime you cut MDF, a kitten dies, or at least sneezes a little bit on some dust. So that would be a super awesome thing for somebody to do who's not me and not right now. And really, it's not that bad. I've seen much worse. They've been cleaned properly in the past 3 months. All right, where are we at? I think we're actually at the point of reattaching the ventilation and then firing up the laser. So, let's untangle here. Cameras and things. Okay. So the laser is a system of tubes. The tubes fire the laser goes through a tube, and then the exhaust goes through a series of tubes. Not unlike the internet. I'm throwing things, don't mind me.
Okay, our insurance policy doesn't cover this.
Our insurance policy is expensive.
So no dime.
Like most of them. Oh hey, my phone hasn't been charging anyway. Meh. Hi science. Yes, a series of tubes. The laser, like the internet, is a series of tubes. Hell, I am a series of tubes. Like cardiovascular system and stuff.
Did I hear you needed a battery?
Oh, you're awesome. Thank you, Alice.
As long as it's not Apple.
That's a buttery. Alice has brought me a buttery.
Twizzler as well? It's 16 inches long.
Yes, I would love a 16-inch long Twizzler. Yes, yes, science. That is correct. Alright. Now we manhandle the laser back within range of the ventilation system. And the laser does a barrel roll. Which is its intended functionality.
That sounds very safe.
Yeah, this is fine.
Twizzlers are good.
Everything is fine.
Keep your blood sugar up.
Ventilation system gets reattached. Up here, you can also see there's some crud in this. We need to make sure to clean this out periodically. So that slides into place. And we start screwing it. Oh, dude, I had a minty boost. I made one. I should make another one. They ran on what, like 2 AA's? They weren't, you know, the 20 amp hour monsters you can buy on Amazon for like 30 bucks, but they totally got the job done. And if you had rechargeable AA's, then, well, shoot, you're good for a long time. You just keep swapping them out. I made mine with an actual Altoids container, but apparently Adafruit, when they started selling the kits, got their own like unlabeled Altoids container. Because, I don't know, half the fun of it was eating all of the mints, stuffing all the mints in your face, just so that you had a container for your batteries and your little PCB. Comment. 3 comments. Why are we holy fucking about my wrench action? Good, bad, ugly? Yeah, I take a lot of stuff apart. I usually get it back together. I appreciate the compliments on my silky smooth wrench action. I don't have much action that's silky smooth. Okay. The back's attached. And now we've got this little guy that's got some aluminum tape that's sort of falling apart. So I'm going to shove the duct sort of back where it went, but then we might have to go outside and find some duct tape. And unfortunately, I mean the kind that's actually meant for ducting, not the other kind, which is far more common. But I will make do with some masking tape or carefully interwoven zip ties if I must. Or somebody can go run up to Home Depot and buy us some duct tape. Stretch. Rotate. So Home Depot is open for another 49 minutes or so. This is the part where Eli starts quacking, right? Duct tape. Okay, those are in, but they're not sealed, so it might smell a little bit woody in here if you fire the laser right now. So let's go on an adventure. Alright, USB. And there's a network cable around here somewhere, which just barely reaches. Put the network cable in there. Now we can actually talk to the thing again. Sometimes I wish live streams were two-way, because I would love to hear some duck sounds. That sounds like something fun to attempt. Speaking of things that are fun to attempt, I now need to squeeze out from behind the laser. Hi. It's Dustin.
Oh.
Dustin, we're live on the internet.
Oh, hello, Internet. I was concerned you were talking to yourself. For a
No,
moment.
it's pretty much just science and Eli and I think Shay might still be hanging out over there.
Cool.
On the internet.
On the Internet?
Yeah, it's only shared in the lab Slack, so it's
Oh.
not the entire internet.
Oh.
I thought about it. I didn't feel like having to narrate everything, at least here. People understand, but if it's random people on the internet, then I have to explain a lot more.
Yeah.
And that's a pain. Okay, that's barely going to hang in there, so I'm going to be a little bit of a ninja. And by that, I mean I'm going to look terribly awkward and probably fall over the top of the laser. Okay. Now that that's over with, I've reacquired my car keys. Push the laser back into position. Run over a few cables. Excellent. Let's check and see who's... I don't know who's Goering. Shay said that 17-ish minutes ago. That's probably meaningless. Oh, you know what? My phone wasn't charging because I accidentally unplugged the plug strip. Maybe. Yes. Yes, I did. Whoops. Alright, warehouse adventure. Oh, yeah, it probably is Shay. That's okay, I have a Twizzler. Let's go find some duct tape. We probably don't have any. Alright, we're on a live stream adventure to find duct tape. Good luck. Duct tape?
Duct tape?
Duct tape.
No thank you.
Okay.
That's still alive?
Yeah, it's still alive. We haven't fired the laser yet, so we're going to keep on doing the live stream until the laser's definitely up and running.
Perfect.
So we're going on an adventure because the duct is loose. Hello. Tape. None of that's duct tape.
What's that?
We're live on the internet. We've been streaming the laser repair. So
Oh.
there are people watching, and I'm on a quest to find duct tape, and I haven't found any.
Is Gorilla Tape okay or no?
You have some?
I think it's in my truck. I'll have to check though to say for
Oh
sure.
yeah, if you can find some, that'll do for now till I can get the actual like foil type duct tape.
Oh, I have that at home. Yeah.
Yeah,
Okay.
I can pick up a roll tomorrow. See what Nick's doing. Other Nick. What are you up to?
Working on shift knob.
It's a big chunk of aluminum.
Yes, it is.
New lathe tools?
Yeah.
Nice.
Yeah, pick up a set. Here we go.
Carbide's fantastic.
Yeah, I've watched a bunch of videos on here's how you can ground the high-speed steel. And, do I spend a couple nights learning that at first, or do I spend a couple nights working the lathe and then kind of go into that?
Yeah, it's good to know both, but it's nice starting with a set of known good tools.
Yeah.
So you're not chasing your tail trying to figure out what geometry you need. Or you're not trying to figure out if it's the tool's problem or your problem.
Exactly.
Like that should at least cut something, and if you chip the end off, you at least know that you've chipped the end off, and
Yeah.
you can flip it and get back to it. And then when you need custom stuff, or you don't want to buy a nice indexable tool, then you can grind your high-speed steel later.
Yeah.
All right, sounds like Dana just locked her truck. We're gonna go see if she has duct tape.
Duct tape for?
The back of the laser, the tubes, the vent tubes are coming out. It had some of the like foil, like actual ducting tape, but it tore at some point, removing and replacing and removing and replacing.
So I heard that if you use 3 times the masking tape instead of duct tape, it works better.
It might. I don't know.
I left my key in my purse. See what I got. We have the white Gorilla Tape.
Do we get color choices?
Summarily better, or not as good in my opinion, in my experience with the black, but that's what I have with me.
Okay, I'll make it work.
Besides the black tape.
No, we'll do this for now, and then we'll get some actual like foil tape another day.
Okay.
And if it's
tomorrow morning, that'll help.
sure, that would be awesome. I'm not even sure the laser will have any use by then. Although this video is streaming, and people know the laser is fixed, so the floodgates may be opening. We'll see.
Yeah. So there's
Anyway.
probably a bottleneck, huh?
Yeah. I just said the phrase "the laser is fixed," so I'm probably about to get trampled. So everybody rushes towards the machine. Although, you know what? It still says 0 watts, so that works. Yeah, exactly. We do want to use the right foil tape, but this will get the job done for today. And I've slid the laser in without taping it. Balls. Don't judge me. Too hard. Or two. I actually really don't care. Swivel head, swiveling. Carefully supporting myself on the laser. Boom, fixed it in. Shall go return this to Dana, and we're gonna do a test piece.
You need an extra pair of hands?
No, I'm good.
If you should, just let me know.
At this point, we should actually be done with laser repair, and I'm gonna go test run it. But I've had myself and somewhere between 2 and 4 minions watching online at any given time.
Well, if you need any, I wouldn't even, I was trained on it. I went through 2 training sessions at Factor, but I haven't touched this one.
Someone can get you up to speed soon. I think we'll finally be back up and running. So
it was a 0 watt for now.
It was a 60, and then over time it degraded to a 20 or less, and then we removed the tube, so it became a 0 watt.
Okay.
And now, in theory, I can scrape this off, although I don't know what this is, and it seems quite resilient.
So can you touch the tube with your hands, or do you have to put a cloth over it?
It's not a conventional glass laser tube.
Oh.
In this case, it's a big aluminum air-cooled thing.
Oh.
So it's
I recognize that.
I have a picture somewhere. I don't know if I can go back in the live stream.
Well, you got it going, huh?
I may.
Nice.
This may be. Oh, there you go. There's kind of a.
Oh, there. Oh, it's when you were putting it in.
Yeah. So there's the tube itself.
Oh, it's in that box. Okay.
Yeah.
Gee, you'd think a tube would have roundness.
Yeah. No, it's colloquial tube, not necessarily tubular tube. So it's a big welded aluminum piece, and it's got these heat sinks. Yeah, big heat sink fins. But that way we don't need the water cooling. We don't need the chiller. And it's pretty. Power is pretty constant. And then there's a laser dot that goes on it, and that you align that so it's coaxial, and then everything gets aligned. All the mirrors get aligned, and then you have a functioning laser. So now that the live stream has a couple minutes of me watching the live stream on it, we should probably restore the space-time continuum.
Yeah.
And get back to work. Comments. Yes, science. That's gonna suck to get it off, but it's okay. I accept this. Okay. Laser's on. And it's time to cut something. Let's see what's in the scrap bin. They're giving us a couple more scooches. Scrap bin. So the big thing is we haven't been able to cut some wood. Let's see if it'll cut wood. Grab a piece of this. Don't see a name on it. And we'll cut somewhere sort of towards the middle. Now the hope is that it'll actually cut this in one pass like it's supposed to. It's been so long since I've used a full powered laser, I have no idea if it actually will. Or if that's a reasonable expectation. That was too far. It's focused. Set that as our origin on the jog. Close the laser. And... Ha, FaceTime continuum. I like it. Now we sneeze again. And we align the phone sort of towards the monitor. And we clean our work area by simply relocating everything. That's clean, right? What should we make? I want feedback, I want requests, something simple that I can reasonably draw in a couple of minutes. I guess I could just do something boring and rectangular, but that would be boring and rectangular. A potato? Okay. Here, we're gonna do a potato. There's no internet connection. Screw off. What do you mean there's no internet connection? Apparently that means there's no internet connection, but that's okay. We can make a little dinosaur play a game. I'm bad at games. Okay, we'll draw a potato from scratch and then I'll troubleshoot internet later. So... do like a... you know... What's an actual potato size? Like, are potatoes like 7 inches long, or is that an exceptionally large potato? It's not a banana, so I don't know how big it should intrinsically be. It's banana for scale, not potato for scale. Okay. Big potato it is. Laser potato. There's some eyes. So let's see, can I make an arc? I don't know if I can make an arc. There. Take that. Yeah. Here, should I do Comic Sans just to piss people off? I can do Comic Sans. Make it bold Comic Sans. Yeah. Because I fixed the laser and I can do whatever I want. Within reason. Like fixing the laser. Ha. 60-watt laser potato. Oh, you cannot see the potato. Here. There, have a 60-watt laser potato. I'm gonna make that. We'll make something better in a bit, but for right now, let's see, we'll adjust the stroke size on this. So we'll make that 0.01, so that's a hairline. I hate this because you comment and I can't see things. But you wanted eyes, and I'm not an artist. Send me a potato vector if you want something better. I don't know. Don't judge me too hard. Okay, so this is wood, and Epilogue seems to recommend 15120 for that. We're gonna give that a shot. So, oh wait a second. I bet I can flip this around. I'm a dummy. Then I can see comments and I can see what's going on.